Hi there. Last lesson we looked at what a rational number was and some ways that we could help identify a rational number. And today we're going to talk about simplifying radicals, which has a little bit to do with the rational numbers. So just as a summary from last day, we know that rational numbers cannot be represented by a fraction of whole numbers. They're non-repeating, and examples would be square root of 5 or pi. And on the other hand, rational numbers can be represented as a fraction. They either repeat, like repeat would be like 3, 3, 3, 3, and that can be represented as a fraction, like 1/3, or it could be terminating, like 1.5. So if a square root is rational, it must be a perfect square. So for example, that square root is rational. Likewise, if there's a cube root that is rational, it has to be a perfect cube. So like, whereas square root of 9 is 3, if you take, say, the cube root of 27, that's equal to 3 as well. So those are two types of rational roots. Now, most square roots radicals are not perfect squares, and we may want to simplify those radicals. So we're going to look at two different ways. We're going to look at different ways to simplify radicals. And before we do that, we should be aware of two new terms: an entire radical and a mixed radical. So an entire radical is something like, say, the square root of 60. Whereas a mixed radical could be like 3 root 5. Okay. So in order to rewrite radicals, we make use of what's called the multiplication property of radicals. If we think about square roots, n, the index, is equal to 2. If we're dealing with cube roots, we have n equal to 3. So I'd ask here to give an example of the multiplication property of radicals. So we could do, say, cube root of, and I'm just making, it doesn't really matter what it is, it's just an example. The cube root of 20 is equal to the cube root of 2 times 10, which is equal to the cube root of 2 times the cube root of 10. So that's basically an exact copy of what this is, only using specific integers a and b instead of the symbols a and b. If n is 2, then there are two identical factors in the radicand. We say the radical is a perfect square. For instance, that is a perfect square. So this is stuff that we've sort of looked at earlier with perfect cubes and perfect squares. And we can kind of see a pattern here that anytime the index number matches a number of identical factors inside the radicand, we can simplify the radical. So in this case, the 5th root of 32 is equal to 2. We can simplify that. So the next question I ask here is, what does the index n have to be if you want to simplify the radical n root of 27 to a whole number? Well, 27, if we factor that, that's equal to 3 times 3 times 3. So if we want to factor this to a whole number, we need n to be equal to 3, because the cube root of 3 is equal to, because the cube root of 3 times 3 times 3 is equal to 3. Let me try another example. Let's suppose we're looking at some n root of 64. And we'd like to factor that, or hope we can factor that to a whole number. Well, 64 is equal to 4 times 4 times 4. So that's equal to the nth root of 4 times 4 times 4. So again, n has to be 3 for that to factor to a whole number. We have 3 identical terms of 4. So if we want it to be a factor to a whole number, we need this to be a 3 as well. Okay, so to simplify a square root, we want to factorize the radicand and rewrite the radical such that one of the factors is a perfect square if possible. So for example, square root of 80, we're going to try to rewrite the radicand, this is the radicand, such that one of the factors is a perfect square. So it so happens that 16 times 5 is equal to 80, and 16 is a perfect square. So now we use the multiplication property of radicals to rewrite the square root of 16 times 5 is equal to the square root of 16 times the square root of 5. And since the square root of 14 is 4, we can rewrite the square root of 80 as 4 root 5. Here's another one to try, the square root of 108. We can rewrite that as, let me zoom in a bit, as 108 can be written as, no, not 27, 36 times 3. So that's the square root of 36 times the square root of 3, and the square root of 36 is equal to 6. So the square root of 108 is equal to 6 root 3. Now we don't always simplify square roots. We can actually simplify any radicals with any index. The textbook has more examples on page 215, and in your practice problems you'll be doing some other ones. So that's simplification. On the other hand, we can also rewrite mixed radicals as entire radicals. So for example, let's take this guy. I'm going to call it 3 cube root of 2. It's supposed to be a cube root as well. Well, I know that 3 is equal to the cube root of 27. So that means I can rewrite this guy as cube root of 27 times the cube root of 2, which is equal to, let's say that is equal to the cube root of 27 times 2, which is equal to the cube root of 54. And there's more examples of doing that on page 57. But for now, we can try one here. So the idea is that we want to change this 3 so that it becomes equal to a square root of something. So n is equal to 2. That's the square root. So we need a radical with two identical factors. So that's going to be equal to 3 times 3, which is square root of 9. So that means we can put the square root of 9 in here instead of 3. That's equal to square root of 9 times 7, which is the square root of 63. Maybe I'll try one other one. I'll just make one up on the spot here. 2 cube root of 7. So n is equal to 3, so I'm looking for something that's the cube root of 2 times 2 times 2. So that's the cube root of 8. So that's 2 is equal to the cube root of 8. So I can rewrite this as the cube root of 8 times the cube root of 7, which is equal to the cube root of 8 times 7, which is equal to the cube root of 56. There you go. Try some practice and let me know how it goes.